I think we can use this segment to speak about slow speed bearings and also more specifically that one application pillar of lubrication. I'd like you to start, Bob, because you're a Cat 3 vibe qualified guy. Because when we post these case studies, we'll often see the Cat 3 and the Cat 4 guys making comments and saying, well, I can use vibration analysis to assess and analyze slow speed assets. What would you say in response to that?
I'm not going to. I would not argue with any of those higher level vibration analysts, and with the higher level vibration systems that they could do that. What we're talking about here is, I'm bringing a bunch of other conversations into this. We're talking about the average person, the average condition monitoring person at their competency level, and then at the ease of use. Now, one of the applications I discuss often when I'm doing a training episode is had to diagnose a bearing on a slow speed asset. The asset was about 15 feet long with a bearing on each end. But on top of that asset was 3 chain drive units, a motor, a chain drive, and a reducer. And there was 3 of those. This entire piece of equipment was just shaking enormously when I got there. And so absolutely, you can use vibration analysis to do some slow speed analysis, but try to do slow speed analysis when there is inherent energy from chain drives, from reducers, from motors, from misalignment. And so what I was able to do was this piece of equipment was rotating at 9 revolutions per minute. I took a 20-second sample, a test sample, just to see if I could get good data. And in that 20-second sample, I was able to determine that it was a rolling element problem with that. Not saying that you could not do slow speed analysis with ultrasound, with vibration, but I defy anyone to try to do it on that asset in that particular location and to make any kind of determination whatsoever.
Adrian, what would you add to that?
Yeah, certainly if you have the right data collector, the right accelerometer, the right software, and then the time, you can certainly do, slow speed analysis with vibration. But again, a lot of people don't have the right data collector, they don't have the right accelerometer, and they don't have the time that you need to go out and collect that good data. But with ultrasound, it is very quick and easy. Again, we think about a 1 RPM bearing. It's easily done with ultrasound. Now, with slow speed bearings, you do need to exercise a little bit of patience because, again, we need to collect at least 1 full rotation on our sound file if we're recording dynamic data, which I would highly suggest you do on slow speed bearing analysis, because we do want to look at that in the time waveform. So again, those anomalies, any kind of indication of impacting or rubbing, will show up very nicely in the time waveform with ultrasound. So again, with ultrasound, it tends to be one of the areas in which we shine is with slow speed bearing inspection.